And please take out your 3.3 so that Jack can stamp it because he's such a good student that he runs my life. Where would I be without you, Jack?
I don't know, man.
I'd be lost like a paper in the wind.
Oh my god. Stamp number one. Okay, just go.
Wait, no, it was small.
Like, stamp this way. That is right. Why have you done all of this? What? You just add double it.
I know. Yeah. No, I have more. I have some else. I have like cheesy butter Jose, it took me way too long to get the virus.
Yeah.
It took me way too long.
Like 3 days.
I could see the history.
And I was up like late too.
I feel you, bro. You gotta admit, if I had to say I'm not in class, it would be like, what the fuck is going on? And I still spent a couple days in class talking about it.
No shame. Well, I know why we need to learn.
Yeah,
I mean, I could have done the homework faster, but I wouldn't have learned it. Oh, sure.
Debit.
That's the balance. Like, I have compassion, but it's still chasing through. It's like getting a baby stitches. Like,
Ooh, yes.
I know it's gonna hurt, but I gotta do it.
I usually do it with butterflies.
Yeah, that's true.
I got butterfly stitches on face.
Me too, up here.
Stitches don't scar it. And butterflies scar them more.
It kind of depends. But yeah.
So Santa Barbara, like, temperate something?
Temperate shrubline. Yeah, we call it chaparral or chaparral.
So we have like a somewhat Mediterranean.
We are the Mediterranean. Yeah, there are 5 Mediterraneans on Earth. Like, this is called the California Riviera. As opposed to the French Riviera.
Mediterranean is warmer waters.
Well, Mediterranean oceans are states, but land is largely shaped by the ocean, and like the Mediterranean, we actually have a lot of similar, like we both have a northwest current bringing us cold water. And in the European Mediterranean, you've got a whole separate isolated sea. So there's like the space around Italy and stuff, that's warmer just because it's like a peel out. If you drag a whole bunch of the Pacific across to like the Dakotas, it would probably kind of
There are so many beaches we go to, and after we go to Sicily, the water is like.
So it doesn't matter how it's like, it doesn't matter the temperature of the water, but more the way the water moves.
One begets the other, so I'm not trying to split hairs here, but I think water temperature is primarily a result of depth, wind, and solar radiation. So if you're at the same latitude, you'll have roughly the same wind, roughly the same radiation. The only variable left is depth.
How often do you encounter jellyfish when you're sea life?
Here, never, ever, ever. In the tropics, every day.
How big are they like here? Because in Mediterranean, like where Sicily is, they've got these really small ones that are super like big.
I've only seen a jellyfish.
I don't know well enough to say, but there are like a jillion.
I've only seen a jellyfish hunting for tuna, which is, I mean, like you just go out and open up.
What is it? The tulip, what is it?
Yellow.
You've seen jellyfish while hunting tuna, or you guys seen jellyfish in the act of hunting the tuna?
Oh,
Well,
Got it.
I don't think
but tuna eat
you know how you go like in the
That's the part that I was like,
you go out in the blue and you just like sit there. It's terrifying.
yeah.
Oh no.
And you just like
Bobbing
dangle-
around like eight.
And you dangle your
Not
gun
really.
and just like flash it until the fish come up basically.
Yep. And then you hope that you can shoot.
Yeah, so it's like
my friend.
Yeah, great white open.
My friend in Italy we were in like super clear water, like swimming around with his Italian cousin. He got jellyfish on like his thumb, and he had some reaction to it, and it like bubbled like for a week. It got bubbled.
Sisters.
Yeah.
Okay, sorry kids, I gotta get going. Here we go. Any feedback on the movie last night?
It was nice. Yeah, it was like short. Feels like nice, short.
Yeah, brevity is really nice. There aren't that many brief ones. I gotta warn you that, like, if you like the brief ones, you should go a lot now, because units like 6, 7, 8, 9, 10, they're all like blockbuster length, like 1.5 to 2 hours. And so the short ones end right around here. Remember that the Unit 3 packet has changed. Who was absent yesterday? And we just talked. And let's get back to 3.1 because I want to finish the entire assignment. I can do individual questions, or I can highlight the parts I really like.
We're about to do number 3.
Excellent. I'm gonna try to give you some of the stuff that I wanted to talk about, and as we go in the order of the study goals, please stop me if I'm not answering your questions. Okay. First with animals, and then with plants. Early scientists noticed weird patterns. It became a field called biogeography, which is the life patterns on the planet, on the map. I don't know if you guys realize this, but a lot of scientists back in the day were just collectors for the wealthy. If I have a ton of money, I say, hey, Darwin, I'll buy you a seat on this boat, and I want you to bring me back all the big birds you can shoot, please. Or he'd say, hey, Wallace, I'd like you to go on this boat. I've bought you a bunker, and I'll pay you to bring me potted plants from all over Africa. And there were these wealthy people that had giant collections of dead stuff. I mean, humans always like to collect. It's a good way to show your wealth. You have a collection of stamps, or of Corvettes, or of guns, or of coins, or whatever you want to collect. But it was like a pretty cool thing. In like the 1700s, when, you know, on the news people were like, hey look, we found another part of the world. Like, you can imagine that would kind of pique curiosity, right? Like, if you just happen to flip through the paper and they're like, we found a whole continent, you might be a little intrigued. And there was no television or photographs, and so everybody's like, I wonder what's over there. And the story says, there are red people there with feathers on their heads. And everybody's like, ooh, I wish I could see one of those. Or they said, there are giant birds that run instead of flying. And you can imagine some random Victorian person reading this in a black and white newspaper is like, that would be really neat. I'm curious.
What animal is that?
Ostrich. Emu.
Oh yeah, emu.
Rhea. R-H-E-A.
What is it?
Like an ostrich and an emu.
Nice.
Okay. So, it was actually like really trendy for wealthy people to like send collectors to other parts of the world and bring back preserved specimens. There's places in Europe today where you can see like walls of jars of like 300, 400-year-old snakes in, what do they put in it? What is it called? Formaldehyde? Or
Formaldehyde.
is it formaldehyde?
Yeah.
Okay. So whatever they use to preserve it, I think it is formaldehyde. There's a really famous artist who drew his quote-unquote cabinets of cabinets of curiosities. So he had like a big fancy ballroom with tables in the middle, and he would invite guests and say, "Hi everybody, you're invited, we're going to have a big reptile party this weekend. Bring something nice to share with everyone." And people would show up and he would go, "Ta-da! My collector just got back from Africa, check out what I got." And people would draw them. And science was like exploring the world from the safety of Europe. And people found these interesting patterns. Like, hey look, there are iguanid reptiles, meaning big vegetarian lizards that are greenish. There are iguanid reptiles all over the Americas, but they don't show up anywhere else. When you open the Africa cabinet of reptiles, and then you move to the South America cabinet of reptiles, they look surprisingly similar. In Asia, they had this group of giant reptile lizards called varanids, or monitor lizards. Crocodile. Have you heard of the Komodo dragon?
Yeah.
Okay, that's a varanus. It's a monitor. It's the largest lizard. It's the largest lizard today. They're very primitive lizards. They're very advanced lizards. They actually gave rise. It's the lizard closest to snakes. So you notice they're kind of serpentine in their movement, and they flick their tongue in the same way that a snake flicks its tongue, and they have a forked tongue like a snake. And people go, "Look at this, the Africa cabinet has a bunch of these big old lizards. But if I go to the South America cabinet, I get a bunch of skinny green lizards with spines on their back that we call iguanas." And there's many species of iguanas, but they're only found in South America. And there's many species of monitor lizard, but they're only found in Asia. There's many species of chameleons, but they're only found in Africa. The little curly tail with the clamp hands. Do you guys know that chameleons rock back and forth as they walk so they can resemble wind motion?
Wow.
So if you just put them in a tank, they look like they have Parkinson's. Because in your house, there ain't no wind, but the stupid lizard don't know any better. So he's trying to blend in by being the only thing in the room that's moving. Each of these groups of species lived on certain parts of the map, and people said how weird it is that those plants are so separate from those plants, are so separate from those plants. Nowadays, we all know the answer, but back then they didn't know the answer. It was quite an interesting mystery. Orchids only on one hemisphere, not the other hemisphere. There's a ton of these patterns. I wish I was more prepared to tell you them. In science, there's thousands of these biogeographical patterns, and I'm sorry to admit that I used to always remember them back when I was more active in zoology, and I kind of am starting to forget those. I should prep my notes before I teach the lecture, I mean. So here's a great example. Placental mammals develop entirely inside their mama. Placental mammals pop out of mama with great effort. You may have heard about this. And when they pop out, for the most part, they're ready to rock and roll. A mama horse drops a baby horse, and within 6 hours, the baby horse is walking. Mama elephant drops a baby elephant. That elephant gets up and nurses within an hour while standing on its feet. As a matter of fact, humans are one of the only mammals that comes out of mama without being fully developed. Do you guys know that? Because our developed brain would not fit through the opening. And so anyway, I'm sorry to discuss anatomy as openings, forgive me. But we actually are one of the only placental mammals that finishes development outside the womb. It's called the 4th trimester. The first 3 months of your life, you're basically an embryo outside the body. You guys notice that for the first 3 months, babies are pretty much
It's a lot more vulnerable.
grody and slug-like. You know, their skull hasn't closed over their brain, for God's sake. They're not done yet. It's like pulling a muffin out of the oven when it's still squishy in the middle. I used to always call it my baby's muffin head.
You can feel their brains.
You can feel their brain.
I don't think
But
you're supposed to touch it.
it's okay. You can touch it all day long.
You just don't want to hit it.
Yeah. You don't want to poke it.
Oh.
You can touch it. It's okay. Your brain's really tough. It doesn't have any nerve endings, so it doesn't hurt the baby.
So going back to like primitive Homo sapiens and stuff, like how did like a sort of ape-like thing take care of its baby like the same way we do, like holding it and like nursing it?
Probably, yeah. I mean, we see that gorillas, chimpanzees, bonobos,
Yeah, what do they do?
and a few others care for their babies.
Like, do they have umbilical cords?
But those babies don't have the same brain size ratio to body mass, so they come out undercooked, but still much more cooked. They're less undercooked than humans. They all have an umbilical cord. All placental mammals have an umbilical cord.
They just break them themselves.
No, or it falls off, it atrophies. You know, left to its own devices, the human placenta separates from the baby, becomes brittle, and breaks off, and all this stuff. Yeah?
It doesn't sound very evolutionarily intelligent to have such a vulnerable being.
Oh, yeah, I mean, we are an exception among
They're
mammals.
really fragile, right?
Yeah, yeah. And you'll notice, like, babies are always fragile, but babies are self-sufficient in basically all mammal species except for about 5 primates, including humans. There's like this, there's this graph of body mass versus brain mass at birth. And us plus a couple other mammals are the only 5 on the tippity tip of that line. So because of the intellect of our species, we sacrifice some baby vulnerability for superior mental capacities later down the road. But there's no doubt that we are some of the more frail babies out there. Placental mammals, in case you guys didn't know this, they build an eggshell. It's a soft, squishy eggshell. It's called a placenta. But you should remember that your placenta was a part of you. Mama ends at the uterus, and you start at the placenta. Inside the placenta, there's a hose that connects to your what used to be your stomach. So please remember that when you were a little tiny itty bitty rice grain inside your mama, or your test tube, probably your mama by then, your mama. When you were a little tiny grain of rice inside your mama, you already had a little tiny skin around you that was a part of you, like the shell of an egg. But it's squishy. It's called a placenta. And it's like liver tissue. It's kind of spongy. Anybody seen a placenta? I had both of my babies at home. I gotta tell you, it's awesome. Like, awesome. Awesome. Oh, hold on a minute. This is one of, I mean, I know that childbirth is super scary. No, but, oh man, super scary, really tough on the body and all that, but it was awesome. Inside the placenta, there's this thing called the tree of life, which is a big old vein that branches out into a bunch of smaller veins that wrap the entire inside of the placenta. And those are on the inside, but on the outside of the placenta, it's just soaking up goods from the uterus of the mama. They travel across a little tiny gap of water, and your placenta lets you suck stuff out of mom, whether or not she wants to. Babies can lower the life expectancy of their mothers very significantly. It's actually an antagonistic relationship. Your body doesn't get to decide how much it feeds your baby. A lot of times, the baby will decide how much it sucks out of you. Very much like a parasite. Because the placenta is a way to suck stuff out of mom and then deliver it into the embryo via that umbilical cord. That's a new idea. The previous plan was this one, where mammals, BITD, used to come out of mom at about that size. You know, that makes it a lot easier to deliver them, I would think. You know, it wasn't my body, but it looked kind of hard for my wife to get the baby out. And I could imagine that if the baby was like this, it would just go blip, come right out. You wouldn't even know. They'd walk into work one day and blip, oh, there's another one. No big deal. Marsupials, they'd pop out a little baby, bloop, little tiny one. And that thing climbs up mama like, what the hell, I'm not done. And they jump into this big old pouch on the front of mama. Marsupials have a pouch. Think of kangaroos and koalas and stuff.
Wait, they're actually like this big?
Or smaller.
They're tiny and they crawl up the pole.
I've heard that koalas, when they come out of mom, are smaller than a black
The
bean.
mom doesn't even notice. What the heck?
I don't know what she notices, because every time I talk to koalas, they won't talk back. I don't know. But I can tell you that when that little thing comes out of mama, it crawls up the fur, hops in the pouch, and attaches itself to a nipple. Inside that pouch, it's just like wearing a shirt halfway up over your body. There are boobs. And actually there are more than a couple. And each of those will nurse one of those little embryos. So instead of latching onto mom internally and parasitizing her, they latch onto her outside and parasitize her. Yeah.
So, okay.
Yeah.
Penguins have that little thing over the babies.
No, they're just fat. They have one of these.
Has that nothing to do with?
Nothing to do. And seahorses are fish, not mammals.
Okay.
It's not really a pouchy. Yeah.
So why are marsupials?
So why are marsupials?
No, they live in Australia.
Yeah. Is it because of the warm, stable weather?
No? Why are there marsupials only in Australia? Come on!
They can't get off of it.
Okay, fine. Stop. Zip it. Let's do the bonus question first. What is the only exception? You have a marsupial in your neighborhood right now. You may never speak again. The opossum, that's right. Oh, I saw your little handprint at Star King yesterday. So adorable. Yes, but you may never speak again. But opossum, you're right. Do you guys know that that's the only animal whose name can be written two totally different ways? Possum and opossum.
Is there a difference? Oh, that's pretty awesome. They're really scary.
Regional thing.
They're like trash cans.
Oh, they horrify me. Yeah. Plus, they look like a half-bird rat.
Yeah.
Yeah. If you like pour gasoline on half a rat and light it on fire, you got yourself an opossum right there. But then you put some fangs in there. Yeah. Okay. So hey, guess what? While all of you were sleeping, she had the answer to the warm-up. Why? Continental drift, and what's love got to do with it?
What?
Yes. I mean, so what? What do you mean? Like, yes, what about continental drift? That's a part of the answer, but what's the right answer? Yes?
Isolation.
Oh, well, that is a part of the continental drift answer, yes?
Continental drift caused you.
Thanks for raising your hand, Jessica!
Yeah, because they were all together at one point, and then they drifted apart.
Yeah, just like what she said, and then what? You're not talking. But no, yeah, you're kind of right. But they got stuck how?
Isolation.
And then what happened?
And then they evolved.
Separately.
But why were they all in that little area?
Fine, here we go. A long time ago, all the mammals were marsupial mammals. A long time ago, when all the continents were mashed up together in one megacontinent called Pangea, I think,
Yeah.
all the mammals were one mammal, or whatever, when all the land masses were connected. I think it's actually after Pangea, when it started to peel apart. You know, like if you take an orange peel, and you peel it in one piece, it kind of splits into like a big round thing and a little ribbon and another big round thing. That's sort of actually what the continent spreading looked like. So they went from Pangea to like, as they started to stretch out, they were all marsupials. Australia broke off, and for a little while, Australia had marsupials and everybody else had marsupials because that was the only kind of mammal. Then, in one place, the placenta evolved. And apparently, I've never understood why, those mammals just crushed those marsupials. Somehow, the placental mammals are better. I don't know why leaving it in the oven is better than putting it in the pouch. I don't know. But for some reason it is, clearly. Because every marsupial species on every landmass was outcompeted by placental mammals, except for the opossum. And of course Australia, which was geographically isolated from continental drift. Australia was stuck on its own separately, so the placental mammals just couldn't swim that far. Imagine having like an island of the dinosaurs, where the dinosaurs were left behind and the rest of the world changed and there was the land that time forgot. Well, that's Australia.
Which is what they have, like, huge, like, weird insects and spiders and, like, gnarly stuff.
Yeah, that's right. They have an entirely different set of diversity because they broke off a long time ago. Imagine you take a snapshot, of the ancient Earth, and you just leave that, while the rest of the planet keeps changing in their own different directions. There's this little snapshot, this time capsule on the bottom over there, that's kind of been doing its own thing. Yeah.
So is continental drift, like, from Pangea, like, still happening as fast as it did, like, or has it slowed down? Like,
That's actually a hot topic.
We can't tell, but like...
No, we can. That's actually a hot topic in geology. It appears that there are periods during which the continents drift at slightly different paces, but it actually also appears that there are parts of the planet where the plates are slipperier, if that works for you. So the plates move, and then they get over the slippery spot, and then they move, and they get over the slippery spot. So there is two conflicting issues, that overall the rate of plate movement is generally the same, but there have been instances which we think are because of slippery magma, that there are some parts of the Earth where plates seem to travel at a different speed. It is a constant, roughly. And then...
Go ahead.
Since, like, you see that Pangea started as one big thing, then we started drifting around, there's going to be a point where we drift around and collide again?
Yes.
Yeah.
And by the way, Pangea was like the third or the fourth mega landmass. Yes.
So like it broke apart and then drifted back?
What he said. And then broke apart and drifted back, and then broke apart and drifted back, and broke apart and became Pangea, and then broke apart, and then It's already got a name. We already have maps of what it'll look like when Pangea 2.0 happens. Oh my God, slow down! I can't teach you if you're all this interested. Get a little dumber, please. Yes?
Okay, so since we're talking about, like, Australian species, have you, like, seen any footage of, like, this spider that's, like, huge and can, like, jump? It's like from Australia.
Yes.
Seen it?
The one that lies on
The interplate spider?
Oh,
Bird eater, yeah.
it jumps. It's so freaking.
Like the land's like moving the opposite way, though, right?
It's not as stable as you might think. The angle of the dangle of the planet changes, gravitational forces change, the shape of the Earth's orbit change, and the relationship between orbits changes. So it's not like a single set of perfectly choreographed moves that keep crossing. they are all kind of subjected to different forces at different times. So one time they'll go like this, and then maybe they would reverse or something. I don't know. I don't mean to say that there's any particular order, so I don't know which way things are going or going to go. Yeah. Oh, absolutely. So we know that climate changes naturally, and it has a zillion times. Like I told you at the beginning of the class, the only constant is change. Climate change is the norm. By the way, what worries much of the scientific community today is the rate of change, which is not within normal variation. Does that make sense? You know, we all grow. But if all of a sudden you sprouted an extra 2 feet of length, we'd be like, that's a little fast, bro. That might be hard on the bones. That's the issue with climate change.
You get stretch marks.
Right, stretch marks, yeah.
Can you explain, like, clearly, like, what the difference between a biome and a biotic province?
I could try. So let's bring this back together, because I'm glad to see that I have hooked some of you in this conversation, but we're spreading a little too thin with our time in the study goals. Alessio's question was, what's the difference between a biome and a biotic province? And they're kind of similar, but they're looking at two different things. Biome looks at the physical conditions. So you could say, up here there's extreme seasons and cold in the winter, and down there there's extreme seasons and cold in the winter, looking at the physical conditions. You could say the tropical rainforest in Brazil is a lot like the tropical rainforest in New Zealand. Because, you know, they have like rain every day from 1 to 3, and an average of 300 inches a year of rainfall, and temperature extremes between these brackets with an average here, and that's the same elsewhere. Because a biome is defined
by the characteristics.
Physical characteristics. Physical. So altitude, elevation variability.
What's latitude versus...
And then that physical reality tends to create similar wildlife. So if you're adapted to the tropics in one place, you're very similar to what's adapted. Those are the provinces. Biotic provinces are clusters of diversity that are related. That often includes multiple biomes.
Oh, multiple biomes inside of
right.
Biotic province?
Right. So if you look at the Americas, there might be one group of flowering plant that's spread throughout the Americas. That's a biotic province, even though that flowering plant has evolved into different species in different biomes. One adapted to desert, one adapted to forest, one adapted to alpine. Does that answer your question about the distinction?
And like also latitude and altitude and longitude.
Yeah, those are the other variables that define a biome. Yes.
What is
Physical
latitude?
characteristics. Latitude is like ladder rungs. What line on the planet you are. Where
And longitude is the vertical ones?
Right.
Okay.
That doesn't have a big impact on biomes.
Right.
Okay.
Is the biotic province the same as like the realms?
You know, they have a different history, but they were both those patterns that we identified when we looked in the cabin. So check this out. In Australia, all the jobs that are done by marsupials are the same as the jobs done by other species in the placental parts of the world. You would think that a flying squirrel is a pretty obscure niche, but believe it or not, it made sense in Australia. So when the placental mammals evolved elsewhere, they also created they also evolved a placental flying squirrel. There is a marsupial flying squirrel in Australia, and in the rest of the planet, there have evolved a variety of placental, like you and me, flying squirrels. There are marsupial wolves and placental wolves, rabbits. The groundhog is very similar to the wombat, but it gets even wackier. Check this out. There's a spotted forest cat in South America, which is extremely similar to a spotted marsupial cat that used to live in Australia. There's even a marsupial anteater. Like, that's some crazy Dr. Seuss Baby Jesus stuff. Like, who would have invented an anteater? A big old mammal with a slow metabolism that walks on its knuckles because its nails are too long. They walk like this. With big old shaggy coat. And their entire diet is based on a little skinny tongue that they slither down ant hills to suck out thousands of ants a day. That's their whole diet. That's a weird niche, right? Like, how the hell did that evolve? But that idea basically evolved twice. There was a marsupial version in Australia too. The marsupial anteater. You come up with a weird mammal, and there's pretty much a marsupial version in Australia, or at least there was before the placental version replaced it. First and second?
I have two questions. First of all, why does an anteater have the nails up to this?
Because it helps them get into the, once the hole starts to collapse, they go, and they swipe off a bunch of dirt so they can get down to the hole again.
And, it said that the marsupial mammals are limited to Australia. So, is there just, is the possum the single marsupial mammal
Yes.
everywhere else? So they
Yes.
don't have any others?
That's right. That's right. Second was you.
What is that, like, feathery thing around the anteater? Like, is that
Fur.
its tail?
Yeah,
That
fur.
is so weird.
But, like,
looking,
it
I
looks,
hate it.
have you ever seen one of those?
Oh yeah. I've petted one. They're dirty they're unbelievably dirty animals. They have like funk growing on their fur.
The grossest thing I've ever seen.
They smell horribly. They smell like
But all
a
they eat
rag
is
dumped in a
ants.
swamp. What?
All they eat is ants.
Yeah, but they move slowly. Their metabolism is kind of weird because they're digesting ants. And so they kind of are like sloths. And so they never move fast enough to shake the rain off, and they're in the tropical rainforest, so they get rained on every day. So they grow colonies of algae and moss and funk. Yeah.
So, like, one day there might not be any marsupials left.
It follows the reason that one day nothing will be left. So I don't know.
Wait,
Sooner
is
or
that,
later, right?
is that like striped
I mean-
tiger dog a real thing?
What?
The striped tiger dog?
No, it's make believe.
Like, is that still alive?
Not anymore.
What side is the marsupial? And
The right.
The right is marsupial?
Yeah, that's what I was saying.
All right.
They look kind of weird.
Now.
Those are all ugly.
Now.
Yeah, exactly. I said so.
Either that was a really engaging conversation, or half of you have had totally separate, independent conversations in parallel to my conversation. But either way, we got to kind of hustle. I have a couple of cool examples to show you of other trends in evolution, because I want you to remember that species do not evolve in a vacuum. Thinking of how species evolve over time as the continental land masses are moving is just the intro. The punchline to this chapter would be that communities evolve together as a whole. The species evolve in response to each other. You know, if you always lived with another person, you would eventually adjust to living with that person. The same is true of evolution of individual species. They evolve in a way that takes into consideration other species around them. Either predators get better at finding the prey, or the prey gets better at escaping the predator, or competitors evolve so that they waste less energy by competing with each other, and they diversify, and they split. Or sometimes they become what's called codependent. You guys know a codependent relationship, right? Like where one person can't be alone from the other person. It's like, I can't function without my wife. I mock those people. I can way function without my wife. Just kidding. Don't tell her I said that. She hits me. Stop. Okay. So I don't know if you can tell what's happening there, but there's a little ant pulling out a little jujube. There are these trees called acacias. They're from Africa. And if you walk right here...
Late.
Still top though.
Do you want us to all go to He's grabbing some of the
You'll notice that those trees have these crazy spines.
Looking for.
Yes, because they're crazy spines. Now, there are many different acacia trees. There's one tree that instead of having a spine like this, the spine has like a little trap door on the side, like a thin spot, like that.
Oh, wow.
And you can see that this has a waxy coating. I'm scraping it with my fingernail. Maybe you guys see that I can like scrape a line into it. This waxy coating that I've removed here, so you see where that whiter color is, that comes off. That's a wax. I think it helps them lose less water to evaporation because they're from an arid environment. So when you cover it with wax, it sweats less or something. Anyway, they make this waxy coating, and then this species on the screen, it makes a plug of wax that's on the inside of the spine, and the wax also has a bunch of sugar. If you eat those, they taste kind of like chewy, sweet candies. But they're really small. They wouldn't do much for you. They are, however, the only food of that ant. The ant cannot live without the tree. They only live in the root mass of these trees. It's the only place in their entire universe where you'll find that ant. And the ant has no diet except those little jujubes that the tree makes. Interestingly, the tree cannot live without the ant. Because the ants, when they digest the sugary, waxy stuff underneath the tree, something about the chemistry in the soil supports the tree. I'm not really clear on what that is. I don't know if the burrowing activity of the ants stirs up the soil, or if ant poop is like a good source of ammonia or something. I don't know. But somehow, the tree needs the ant. And you know what's even more cool? If you walk up to one of these trees and you knock on it like a door, the ants will swarm and attack you. They're like bodyguards to the tree.
That's so sick.
So you can imagine some giraffe goes like, and starts munching on the tree, and the ants like come storming out, and they climb up the giraffe, and they bite until the thing runs away, and then they all walk home. Yeah.
When I was in Africa, there was like a bush, and it's called the whistling bush or something, and it's like that, but it's like a ball, and it has a ton of holes in it, and like spikes. The tree has spikes, but it's just like holes, and then inside the holes, like ants live in there, and so then when like zebras try to eat the tree, because it like makes, when wind blows, like makes a lot of noise, and then the zebras try to eat it, and the poisonous ants like get in its mouth, and it just goes away.
Very, very similar to these. There are a number of these relationships where you have partner species. I'll be with you in a minute. You have partner species. So here, the tree is a partner with the ant. The tree does not do as well without an ant. I think that they can't live at all without an ant. Without the ant colony, I mean. And the ant colony has no source of food outside the tree. There are many of these examples. Which one evolved first?
Tree.
With no ants?
Together.
Or the ant with no trees?
Probably at the same time.
Yeah, these are called co-evolutionary relationships. Co-evolution. You evolve together. Probably there was a generalist tree and a generalist ant. And then they found a special harmony when they lived together, and over time they've specialized to just depend on each other. They've become codependent. There's other examples of these. I might have told you in class about this moth that only lives for 2 days a year. The 2 days when the flower... Okay. Same sort of thing. They were probably generalists over time and then specialized to complement each other. Now they're two separate species that live in a obligate symbiosis. They're stuck with each other. Do you have a question about this?
I was wondering what you were calling the little thing with the antes, like a juju something.
Oh, jujube, like a candy. I mean, it's shaped like those. You know what jujubes are? The
don't.
candies you get in boxes that are gummy candy.
I've never heard of that. No.
They're just like little
I think I've seen those, but I don't know what they're called. Jujus.
Another cool pattern in biogeography is this one. And it's the example that everybody's heard of. Darwin's finches on the Galapagos Islands.
Oh, yeah.
Where a single ancestral species radiates to many different environments. And from the same starting point, each of them specializes for a different task because their environments are different. So on an island with a lot of cacti, the finches have evolved a way to feed in the cactus. But on an island with a lot of seed-bearing grasses, they've evolved into a beak that lets them crack seeds from grasses. And on an island with a lot of big trees, they've evolved into the shape and characteristics that help them eat out of the trees or whatever. Adaptive radiation, one of the big patterns. And this is one of the classic types of evolution. But there's one thing that I, in particular, find really interesting. Now, everybody knows the dolphin, but what's the other thing?
An evil dolphin. Yeah.
Yes, but what is it?
A unicorn.
It's carnivorous, but all dolphins are carnivorous.
Shark. I'm so scared.
It's not a shark.
That's a dolphin, though?
Dolphin.
No, it's not a dolphin. Nope.
It doesn't eat bigger fish.
Okay, back to me. Back to me. This one is a dolphin, and this one is a dinosaur.
What?
They never lived in the same ocean because dinosaurs were extinct before mammals returned to the sea. Their most common ancestor, their most recent common ancestor, was probably some sort of like a giant amphibian, like a humongous salamander newt sort of thing. I don't really understand the evolution of mammals. I can't remember where they came off. Did they come off amphibians or did they come off reptiles already?
Amphibians. They came off that little guy that came out of the water.
You know, I think we may be stabbing in the dark a little bit and simplifying a little bit, but it's safe to say that the dolphin is a very new group of mammals. I'm certain of that. Because mammals returning to the sea was like a pretty new idea. First like a hippopotamus, and then more like a whale, and more like a sea cow, like a manatee, then more like a whale, and then shrinking and growing into these small dolphins and the giant whales. Way before any of that happened, there was this dinosaur that looked surprisingly like a dolphin. I mean, if you look at them, they both have that humped forehead, a recurved dorsal fin, a horizontal tail fin. They have pelvic and pectoral fins in roughly the same position, although dolphins don't really have pelvic fins anymore, I think. They both have a snout. They both have eyes that face the same direction, so their vision covered the same spectrum of their field of view. They both swam in the same way. They both chased their food in the same way, and they both captured their food in the same way. Look, I've rubbed all the wax off it, now it's brown. How can these things be so similar if they don't have a similar common ancestor?
Because they play the same niche.
Yeah, a lot of you are on the same track, and Alessio said it in a pretty good way for a nerd. He said they all evolved to fill the same niche, and if you're a nerd, you already know what that means. But another way to say this is they evolved to be similar because they're doing the same job.
Fish in the ocean.
They eat fish in the ocean, by the way, as a chase predator that tends to lunge vertically. So they spook stuff from below or from above. That's why they have a horizontal fin. You know, it's funny. The dinosaur is actually 4 to 6 times the scale of modern dolphins. But that's because the average fish in the ocean is 4 to 6 times the scale of the ones today.
Everything was bigger.
Yeah, so when everything was bigger, they basically were the same in scale relative to their diet as the dolphin is to their diet.
So that's why they had sharper teeth, right?
Maybe. They definitely had bigger teeth.
Yeah.
Yeah.
Do you think if that's what dolphins look like today, people would like dolphins as much as
I think not. I think not. Check this out. Both of these snakes are very distantly related. One of the interesting patterns that we find in biogeography is that this chunk used to be stuck to that chunk
too many noises. I'm sorry if this is too engaging. Finish your conversations elsewhere, but don't interrupt. This chunk used to be stuck to this chunk. And at the time, all of the snakes were large, terrestrial, lived in swamps. Similar to like a boa, like the Burmese python we saw yesterday, kind of in that ballpark. They were like big, dumpy, ground-dwelling snakes. And the pieces split, and they didn't interchange anymore. So then they started to evolve independently. In the New World, a few snake species became venomous, a few snake species became arboreal. In the Old World, a few species became... Reminder, we're going to talk about these snakes again tomorrow. Sorry to not plan my time better. Bye. Tomorrow's fine. Can you please stop the video for me?